Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little more multiplying. In earlier videos we've looked at what to do when you have got decimals in your numbers. But we always did things like 87.2. Here we've got a whole load of naught points and they can be a little more confusing. So just for starters, of course, when you're doing anything with decimals in, the first thing you do is throw all the decimals out. So our 0.073, we're just going to pretend is 73. 0.0054, we're just going to pretend is 54. And either by grid method or compact method, you would come out with 3,942 as your answer. So clearly those are the right digits, but we need a decimal in there. Now, we can count up the number of decimal places in the question. 1, 2, 3, 4, 5, 6, 7, and we need that many in the answer. Okay, that's one way of doing it, and that is certainly a good way. So let's have a go at doing that. We need 7 decimal places in the answer. So there's 1, 2, 3, 4, 5, 6, 7. Please note, it's not 7 zeros and then those numbers. It's 7 altogether, including those numbers. So there we have 7 decimal places in our answer. Okay, so that's certainly one way of dealing with it. Another way of dealing with it here is by taking your answer and just making things 10 times bigger or 10 times smaller, depending on what you want. So what we're going to do now is we're going to set out a whole load of sums that look like that, but all differ slightly by where the decimal point is. So this is where you come in. You will need to write down, we're going to start off with 73 times by 54. And then we're going to do a whole load of different ones. I'm just going to do a few and then you're going to do a few more. We can have 7.3 times 54. We could have 730 times by 5.4. 7,300 times 0.54. Those will do for the moment. And then we're going to do some more. You can make up your own. So let's just look at these. That first one we know is 3942. We know that, we've been given that. This next one down here is the same as the question above it, but it's 10 times smaller. What we've done is we've picked up a decimal point from here and we've moved it there. So we do the same in the answer. 3942. We pick up the decimal point and we move it once to the left. There we go. Same one here, we've again got a 3942, but what have we done with the decimal points? Well, this one has moved one place to the left, as we had before. This one has moved one place to the right, so let's do that with our answer. Here's the decimal point as it starts. It moves one place to the left because of that, and one place to the right because of that. So that is in fact exactly the same as the top one. What about down here? Okay, so this one, let's write the numbers out first. 3942. So again, this one here, decimal point started here and it's jumped 2 places to the right. This one has jumped 2 places to the left. So the decimal point on this, exactly where it was before. This one's got 100 times bigger, this one's got 100 times smaller. Do you see how that works? Okay, there's going to be some on the next page for you, so grab your cup of coffee time. Just in case I forget, this actually says mug of coffee on it, in case I forget, because I can be a bit dim like that. We Batty Boffins are renowned for it. So I'll see you in a minute with a custard cream, a cup of coffee and a little more for you to do. As promised, here are some for you to have a go at. All of these questions use 7 times 68, which is 476. I'll just give you that, you don't have to work it out. And here are some variants, which are the same numbers, just with decimal points in different places. Some have got zeros at the end, some have got decimal points in, quite a lot of decimal points in some of them. So all of them are going to have 476, but with decimals in different places. So have a go at those and we'll work through them together afterwards. Right, let's work through those. I've written the 476 next to each of them, but I've left a bit of a gap at both sides in case I want to put some noughts in front or some noughts afterwards, and I'm going to put those in red. So for start off, we started off, the 7 is just the same, and the 68 has had its decimal point moved one place to the right. It's got 10 times bigger. So we do it with here. The 476, we jump it one place to the right. We need to put a 0 in there so we've got something to put the decimal place after. There you go, 4,760. For this one, the 68 is the same, but the 7 has had its decimal place jumped one place to the left. So we do the same here. Here's the decimal place originally, and it jumps one place to the left. Okay? On here, we've got two different things happening. The 7 has had it jump one place to the right, and the 68 has had it jumped two places to the left. So we'll start off here, one place to the right, over that invisible nought, and then two places to the left. So that one is 10 times bigger than original, and that one is 100 times smaller than original. So we end up with something 10 times smaller. 10 times bigger than 100 times smaller ends up 10 times smaller. Right, quite a lot going on this one down here. For this one, that's got 100 times bigger, and this one has got 10, 100, 1,000, 10,000 times smaller. Please note the one that comes after 1,000 is not a million, it's 10,000. So 2 places to the right to make it bigger and 4 places to the left. All in all, that's going to be 2 places to the left. So you end up with 4.76. Okay, and the last one down here. 1 place to the right, so that's 10 times bigger. 1, 2, 3, 1,000 times smaller over there. So 10 times bigger and 1,000 times smaller is actually going to end up with, again, 2 places to the left there. Same thing. Quite different looking sums, but they end up being the same thing. Okay, happy with all those? Now, these ones are all multiplies. But of course, I'm sure you know that any multiply sum can be written as a divide. We could say 476 divided by 68 equals 7. Yes, any multiply can be turned into a divide. And we can use the same kind of thing here. But you need to watch out. There's a little sneaky bit in divides, which I'll talk about in the next video. I'll see you then.
Mwahaha!